Hello everyone, welcome back to the Cracking Google in 21 Days series. My name is Puneet Kansal. I am the mentor for this particular series. In this series, we are covering 21 most important topics from DSA from Google point of view. Means we are covering 21 topics from DSA with the by taking the example from Google. So we are solving the Google problems and trying to understand 21 most important topic from DSA. So both way this is benefiting us. One is the people who want to understand DSA, they can also join this series because we are covering 21 most important topics from DSA. So DSA, if you want to cover, you can join this series. And if you are preparing for product based company, any product based company, actually not only for Google but any product based company, we are solving the quality questions actually in these sessions. So you will get benefited if you are targeting for product based companies. Okay, so let me start with today's session. In today's class, we will discuss about the divide and conquer technique. We will discuss about the divide and conquer technique. We will solve a problem. We will see the magic actually. We will see today the magic of divide and conquer. How divide and conquer can solve the problem so efficiently. This magic actually we will see today. Although this is day 9 in this series, okay, we have already covered 8 lectures, but you don't need to worry. If this is your first lecture, you can join it. You after today's session, you will start feeling okay, yes, how really divide and conquer is useful. And this is really helpful to reduce the time complexity also. So we will take one Google problem and we will apply divide and conquer technique over that to solve that problem, and we will see that okay, really this is making amazing impact. This technique is making amazing impact. No prerequisite. If you are thinking about prerequisite, no prerequisite for this session. Just join it, enjoy it, and you can go. Although already 8 sessions have already gone. These 8 sessions have already gone. Today we are covering divide and conquer. In this lecture, we have already covered mathematical partial sum, sliding window, two pointer, bit manipulation, recursion, backtracking, sorting. This already done. If you want to watch these lectures, go to the description, check out the link over there. You can join this course. You can join this Google course, and you will also get certificate if you will complete all the videos. And you will complete all the videos because we are solving the quality questions. We are solving the quality questions and covering all the important topic in the DSA. So definitely this is going to be beneficial for you. You can register for this course. This is free of cost. Just register for it, and you will also get some assignment and all that stuff also. So you can register for it and you can watch the previous video also. But okay, let's start with today with divide and conquer. And let's see how divide and conquer really is helping us to solve uh, a problem, and reducing the time complexity also. So fine, okay. And after this lecture, okay, we will cover all different topic, all the important topic like binary search in this series, matrix, hash table, string, linked list, tag, queue, binary tree, BFS, DFS, greedy, dynamic, all the important topics we are covering in this series by using the Google problems. Okay, by taking the help of Google problems. We are just implementing all different things by taking Google problems. So both way this is helping us. Fine, okay. Before proceeding, please write in the chat box if I'm properly audible or not. Please confirm me, anyone. Please confirm me if I'm properly audible or not, so that we can proceed on. Then we will see the magic of divide and conquer. How divide and conquer is really helping us to reduce the time complexity. That we will see today. But okay, before moving on, anybody please write in the chat box if I'm properly audible or not. Anyone, please confirm. Okay, fine, okay. You can confirm that in the chat box. Otherwise, okay, let me move on with today's problem. Let me show you the today problem. So here is the today's problem. That is, we need to find the power of a number. That's it. Look like very easy. Means implementing power of x power n. We need to just calculate x power n. That's it. That's it. This is what we need to do. X power n. This is what we need to calculate. Maybe okay. For example, x value is 2 and n value is 64. Okay, let's suppose. So what we need to find out? We need to find out x power n, that is 2 power 64. Simple, very simple. Looking like very simple problem. Okay, but still the problem is from the Google. Okay, let's see what they want from us actually. What they want from us, how we can solve this problem. Any idea coming to your mind, you can share in the chat box. Anything, how you will calculate the power of a number, if anything coming to your mind, you can share. Means anything. So okay, let me share one idea from my side, which is I can say, okay, approach one, brute force approach I'm sharing. Very easy actually. This problem also looks like very easy. Just I need to take the power of 64. What I need to do, I need to multiply 2 how many times? 64 times. That's it. I need to multiply 2 64 times. That's it. So just I can start a loop starting from 1 to up to n, and every time what I'm doing, I'm just multiplying this number, this x, with 2. Every time whatever is the previous value, multiplying it every time with 2, every time multiplying with 2, 2, 2, 2, 2, 2, 2, 2, 2, and then we will get the power of x power n. We will get. That's it. This looks like very easy. But why these people are asking this question then? Can you tell me, okay, in the chat box? Can you please write in the chat box? This is very important that, okay, you participate and you reply to the questions, so that we can get connected, and we can get to know, okay, really how divide and conquer is working, and we will try to optimize this problem. Fine. So first of all, please reply in the chat box how much time this approach will take. I'm finding x power n. Simple. I'm finding x power n. What I need to do? I need to multiply x n times. That's it. I will execute a loop which will execute n times, and every time I will be multiplying that number with, for example, x is 2 with 2. Or maybe I can take a temporary number. Then I can multiply temp into x. Every time I'm multiplying with the x and updating my temp, so I can return that this temp variable. That's it. So can you tell me, can you write please in the chat box, can you people, anyone can tell me how much time this will take, how much time this approach will take to solve this problem? Can you write in the chat section? Can you please write in the chat section how much time this will take? Anyone, please write it. So let's make it two-way communication so that we can understand easily everything. This will be more interesting. The session will go more interesting if you will participate. Please participate and please reply how much time this will take. Otherwise, you can notice here is that, okay, there is one loop only. And how many times this loop is executing? N time. That's it. This loop is executing n time. That's it. So what is the time complexity of this code? Order of n. That's it. This will take order of n time. This loop is executing n time only. So to solve this problem, we come up with one approach in which we are multiplying the number same again and again. That's it. How many time? N time. In this case, okay, n value is 64 time, and we are getting the answer. That's it. Good morning, Thomas. Nice to see you back here. And there is let me remove the mouse from here. Yeah, it's evening in India. Yes, Raj, you are right. Okay, Raj is saying that I was trying to enroll to your DSA course, but I guess the course are only for people in India. Payment methods are problematic. No, it's not like that, Raj. This course, some people from USA are already attending the DSA course. So you can means try, you can communicate with the uh, team, okay, and you many people are attending from the USA itself. Okay, fine. So let's focus on this thing. Nice to see you here. So today we will see the magic of the divide and conquer. Okay, let's at least complete one topic today. One topic, divide and conquer. Let's make it cakewalk for us. Let's make the divide and conquer cakewalk for us. Let's try to know the gist of divide and conquer, how that is really helping us. This name is very popular. Let's see how that is really helping us. We see one thing, one approach. We see that, okay, to find the power of a number, what we can do, simple. We are just going through a loop and multiplying the number again and again and again up to n time, multiplying x again and again and again n time. We get the power of that number. That's it. So this can be one idea. This is taking order of n time. This is taking order of n time. Fine, but is there can be other approach? Is there can be, okay, this solution is fine, taking order of n time, but these people will ask definitely. These people will definitely ask, can you improve it? Can you improve it somehow? Can you improve it? Can you reduce the time complexity from n to some lower? Can you reduce the time complexity little bit anyway? So okay, any idea from you people you have, please share in the chat section. If any idea you people have, please share in the chat section. Raj codes, I don't know actually if Visa work for the payment or not. I'm not sure about that thing. So you need to connect on the website. You need to go. You need to ask the query over there. Okay, fine, about the course, about the paid course. But right now, okay, let's focus over here on this question first. Okay, fine. Any idea how you can solve this problem? One approach we understand. Very easy. Just multiplying the same number again and again, we get the power of that. Any other idea? Any other idea to solve this problem? Simple. To solve x power n. To find x power n. Okay. One idea I'm sharing from my side. Earlier we were taking order of n time. Fine. Now what I can do? Okay. Let's suppose x values 2. I'm taking one example. X value is 2, n value is 64. Okay, x value is 2, n value is 64. Okay, we need to find out what? We need to calculate 2 power 64. This is what we need to calculate. Earlier we were just multiplying 2 into 2 into 2 into 2 up to 64 times. We were getting the solution, but in order of n time. Fine, okay. Now I'm going to use actually divide and conquer. Divide and conquer approach to solve this problem. Before using the divide and conquer, let me tell you what is divide and conquer. In divide and conquer approach, we divide the big problem into smaller problems. We will keep dividing them into smaller problems. And after dividing that into smaller problem, okay, in divide and conquer, let me write. In divide and conquer, we do 3 steps. First one, we divide our big problem into smaller problem. Okay, after dividing the big problem into smaller problem, we conquer it. We conquer the smaller problem. Conquer means solve the smaller problem. We solve the smaller problem. Fine, divide the problem into smaller problem and then solve it. So maybe, okay, we solve it. Solving the smaller problem is easier. So we conquer it. Fine. After that, one more step we do. 3 steps we do. One, combine the solution of smaller problem. Combine the solutions from the smaller problems. So divide the big problem into smaller problem. Find the solution of smaller problem. And then combine these smaller problem solutions to get the bigger problem solution. That's it. This is what we need to do. These 3 steps we do in divide and conquer technique. Okay, here also we will do the same thing. These 3 steps only. We will divide this is a big problem. Finding the 2 power 64 is a big problem. We can solve it, we can divide into smaller problem. Let's see how we can apply the divide and conquer over here. And you will see the magic. You will see the magic of divide and conquer, how this is reducing the time complexity. You will see that magic. So here, this is the problem we need to solve. What we can do, see, we can divide it like this. I can say that, okay, you please find out what is the value of 2 power 32 and 2 power 32. Then we can multiply them. Simple. 2 power 64 is how much? 2 power 32 into 2 power 32. Okay. I divided the big problem into smaller problem. Again, I can divide it. Big problem into smaller problem. 2 power 32, I can write 2 power 16 and 2 power 16. I can write like this. And I can multiply them to get the value of 2 power 32. Again, I can divide this. 2 power 16 into 2 power 8 and 2 power 8. Two sub problems I'm dividing. Okay. Again, I'm dividing this. I'm saying that, okay, can you solve 2 power 8? You're saying, sir, this is a big problem. Will you please reduce it little bit? Okay, we can reduce it. 2 power 4 and 2 power 4. Finding 2 power 4, 2 power 2 and 2 power 2. Again, you are saying, I'm asking you, can you please solve 2 power 2 and 2 power 2? So you are saying that, okay, write 2 and 2. Multiply 2 and 2. Okay, multiply 2 and 2. After this, okay, I have written 2 into 2. I just written 2 into 2 after this. Fine, okay. So now we can conquer this problem. First step, what I'm doing, I'm dividing a big problem into smaller problem. Now, if I ask you, can you multiply 2 and 2? Now we can multiply. That is a smaller problem. Okay, we can give the result of 2 into 2. Okay. If we are giving the result of 2 into 2, that will be 2 power 2. And we can multiply 2 power 2 and 2 power 2, we will get 2 power 4. Then we can multiply these 2 power 8 and 16 and so on. Okay. So this is how we can divide a big problem into smaller problem, solve it and get the solution. But one important thing, why I'm calling it magic and all that. One thing you can notice here is that when you divide this big problem, this is important. That's it. This is important. Once you divide this big problem into smaller problem, two smaller problem, okay, you can notice here is that this value 2 power 32 is same as 2 power 32. These two sub problems are same. Okay. So you do not need to see, this is very important. You can solve one sub problem. You do not need to solve other sub problem. You do not need to solve 2 power 32 out of 2 power 64. Half time you do not need to multiply 2 with 2. You do not need to solve this. Why? Because already we solve here. We can use the same result. Both are same sub problems. Both are same actually here. Both sub problems are same. You do not need to solve it. You are not understanding. Half of the problems are gone. Half of the time is already gone. You do not need to solve this. Not only this. Again, you are dividing this into two parts. This part and this part. Two sub problems. Again, if you can notice, this sub problem and this sub problem both are same. Solve one sub problem. Do not need to solve this part. Do not need to solve this 2 power 16. Do not need to solve here also. This problem also do not need to completely solve. 2 power 16 is gone. Solve this and whatever result will come, multiply it to itself. That's it. Because both problems are same. Again, we are not stopping here. We divide it into two parts, 2 power 8 and 2 power 8. This problem and these problems are same. So solve it one time. Do not need to solve second time. Solve it one time. Do not need to solve second time. Solve it one time. Do not need to solve second time. Here you can solve. Okay, you can say 2 into 2. Okay, you can multiply 2 into 2. Fine. So see the important part here. While solving 2 power 64, how many operations you are not performing? See, how many operations you are not performing? You are not performing this much multiplications, reducing the time complexity. Divide and conquer is helping us to reduce the time complexity here. We divide our big problem into smaller problem, and later actually we find out that, okay, we do not need to solve this problem again. So due to that thing, we are reducing the time complexity of this code actually. Okay. This way we can solve this problem. Now how this problem will work? Simple. We will multiply 2 into 2, we will get 2 power 4. We will get, first we will multiply 2 into 2, we will get 2 power 2. So multiply this to itself, we will get 2 power 4. We will get 2 power 4. After that, multiply 2 power 4 to itself, we will get 2 power 8. Multiply to itself 2 power 16. 2 power 16 into 2 power 16, 2 power 32. 2 power 32 into 2 power 32, 2 power 64. Okay, fine. Can you tell me? So this way we can solve this problem, and you can see that we are not performing so many operations. Can you tell me? Okay, can you give any guess idea how much time this approach is taking? How much time this approach is taking to solve this problem? To find out 2 power 64 maybe, or to find out any x power n? Can you tell me how much time this will take? Any idea? Any idea which is coming to your mind? Yes, Thomas, we are implementing using recursion, because every time we are dividing our input into two parts, every time dividing the same way, two parts, and whatever result is coming, multiplying that result to itself. Can you please tell me? So Thomas says that this will take log n time. Yes, Thomas, you are right. This will take log n time. And why this will take log n time? We can find out this thing. See, one thing you can see directly. I can show you. So here, this is n. Okay, you are saying log n time. Let me write over here log n. So n is the power here. N is the power. So let me see if we are saying right or wrong. I am taking log 64. N value is 64 here. And I'm taking base 2. Okay, base 2. So what is the base 2 64? What is the value of this? This is 6. 2 power 6 is 64. So log 64 base 2 is 6. So you are performing 6 operations only. Let's see. First operation 1. Here you perform first operation, second operation, third, fourth, fifth, and sixth. 6 operations we perform to calculate this thing. 6 multiplication you done, just that's it. 6 multiplication you done, you get the value of 2 power 64. Yes, you are right, Thomas. This will take log n time only. This will take log n time to solve the problem. This technique is taking log n time. Fine, okay. So this is how we can solve this problem using divide and conquer. Simply dividing the big problem into smaller problem. After dividing the big problem into smaller problem, solve the smaller problem, conquer the smaller problem. Once you solve the smaller problem, then whatever result you are getting, with that result, try to find out the bigger solution. Try to find out the bigger solution, bigger problem solution. Keep trying to find out the bigger problem solution, and finally we get our answer. That's it. So we are applying divide and conquer to solve this problem, and the time complexity is reduced from order of n to log n. Order of n to log n, we reduce the time complexity. Log n is very small than n actually. Log n is very small. Okay, as the n value will increase to infinity, this value will be very small as compared to this value. So this is the answer actually these people are looking for. This is the answer these people are looking for. One more thing I want to add in this. Okay, this is the even number. So this is looking like we are dividing them properly, like 32, 32, 16, 16, 8, 8, 4, 4, 2, 2, 1, 1. What about this? What about if n value is odd? What about if n value is odd? Can you tell me what extra we need to do? Right now n value is even 64. N value is even 64. What about if, let's suppose, n value is 63? What about that? How you will solve this problem? So if you are dividing with 2, then that will be 31, 31. 31, 31 multiply, that will be 62, not 63. So how you will solve this problem? Let me see in the chat box. Yes, Thomas, you are right. This will take Tn by 2 plus 1. This is the recurrence relation you are talking about. Yes, this is the recurrence relation you are talking about. Okay, fine. Let me show you one thing. For even number, we have already seen. Okay, for even number, if n value is even, n value is 64, we already seen the tree, how the recursive tree is built up. Let me see if n is 63, n is odd. If n is odd, let's see how we will divide this problem, how we will solve this problem. Otherwise, that is very easy. Just divide it into every time half, 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 half. Multiply one more time. Like if you will divide this like 2 power 63 in two parts, you can divide this n by 2. That will be 2 power 31 and 2 power 30, 2 power 31. So dividing this n into half, 63 by 2, that is 31. If you are taking lower value, okay, if you are taking lower value, so this will be 2 power 31. 2 power 31 into 2 power 31, that will be 2 power 62. So one more time, okay, one more time we will multiply 2. So that will be 2 power 63. And again we can divide it like this. 2 power 32, 31 will divide by 2 is 15. That is 15. If we are taking integer value, we are not taking the float value, we are taking the integer value. So 2 power 15 and 2 power 15, which is together will make 2 power 30. Okay, we need to generate 2 power 31. This is generating 2 power 30. We can multiply with one more 2. We can multiply with one more x, you can say. We can multiply with one more x. Again, we can do the same thing like 2 power 7, 2 power 7. This will make 2 power 60, 2 power 14. But we need to multiply with one more 2. Just every time multiply with one more 2. That's it. If the number is odd, if this n is odd, every time just multiply with one more 2. That's it. One more x. That's it. So we can handle even numbers also and odd number also. So again multiplying with 2, this will be 2 into 2 and one more time 2. That's it. So this will be the recursive tree for the odd numbers. Recursive tree for the odd numbers. This is earlier we make the recursive tree for the even number. That's it. So n can be either even or n can be either odd. Yes. So what Thomas is saying that x into x power n minus 1. Yes, Thomas, you are right. Just simply multiplying one more time x. Yes, you are right. Simply multiplying with one more time x. That's it. So simple. How we are solving this problem? Using a divide and conquer, dividing our big problem into smaller problem. We take both the cases of if n value is even or n value is odd. If n value is even, then simply dividing in equal 2 power 32, 2 power 16, 2 power 8, 4, 3, 8, 4, 2 and 1. Where just this is going just easy way downside. Here we need to multiply with one more 2. That's it. That's it. So that's it. This is the solution for this problem, and this is taking how much time? Log n. Okay, log n time you can look at directly also. Whenever you are dividing, see, every time you are dividing the number with 2, whenever you're dividing the number, you can take this as a thumb rule. Okay, whenever you are dividing the input number with 2, every time half, the complexity will be log n only. You can take this as a thumb rule. Everywhere in the increment section or decrement section here, if you are finding divide, you are dividing the input, then the complexity will be in log n itself. So directly also we can see that, okay, because every time we are dividing with 2, so 64 divided by 2, 31, then divided by 2, 15, divided by 2, 7, divided by 3, so on. So the complexity will be in log n only. Okay, this is the little idea about, okay, how we can solve this problem using divide and conquer, which will take log n time only, Let's move to the actual problem now. Let me erase everything. Let me show you the actual problem, which is I have taken from the lead code. So these are different examples, like we need to just simply find the power, but input numbers are in the form of float. Okay, they are in the form of float. These are float numbers. So input can be in form of float. One thing you can notice, output for this will be 2 power 10. 2 power 10 is how much? 1024. But in output will also be in the form of float. Or you can say, okay, double in C++. Okay, double or float. Double is bigger, is 8 byte long. Okay, so in syntax actually they mention it, they're using double to store the output and to store the input. Okay, they're using this data type, means which is in decimal format. uh, Fine. Okay, for this input we have this output. Fine. Okay, let's see other output, other input. For this input, when x is this, y is this, so input can also be little bit complication they are making. Okay, little bit more, like input can be in form of decimal. Okay, in points I can give the input. So one thing is this, so here output will also be in the form of like 9.261 in the decimal. Okay, another example if I am taking is that you can see one more thing, power can be in the form of negative numbers. Power can also be in the form of negative numbers. Okay, not only positive, but power can also be negative. So how can you tell me? Okay, can you tell me what will be the output for this example? If you can tell me what will be the output for this example, anyone can tell me what is the output for this, what will be the 2 power minus 2? Please write in the chat box. Please write in the chat box what will be the output for 2 power minus 2. Please write. So what will be the output for this input? Can you write in the chat box? Just simply finding the power. So this will be easy for us then to code this problem if you will reply. Please reply anyone. So Thomas says that simply this is actually Thomas is saying that this is actually equal to 1 upon 2 power 2. Yes, and that is 1 upon 4. Yes, you can say okay 0.25. 0.25. Yes, Thomas, you are right. Let me check out. Yes, you are right. That is 0.25. Yes. Fine. Okay. So let's try to implement this. You please help me. Okay. You people please keep helping me. So I will keep asking some question from you. Please keep replying. Okay. This will make the session more interesting also. I will ask one question and this will improve the learning also. I will first question from my side. I'm trying to code this and you need to help me. First, please tell me if the value in the power, if that is 0, if value in the power is 0, what will be the output? I just provide you one information, the n value is 0. Can you tell me what will be the output? Can you please tell me what will be the output? Please keep replying. I will be keep copying from that your text. So I will just keep copying from there and I will keep pasting over here. Please reply in the chat box. What will be the output if n is 0? Yes, Thomas, you are right. We will just simply return 1. If anything power is 0, we will return x, whatever is the x value, doesn't matter at all. If n value is 0, that will be 1. So simply this is the one base case. Okay, another question. Please keep helping me. What about if n value is less than 0? What about if n value is less than 0, means n value is negative. N value is negative if n value is less than 0. Then can you tell me, okay, how I will solve this thing? Already, otherwise you have already tell me that okay, this is 2 power minus 2 is 1 divided by 2 power 2. So I need to write it this thing like this. That's it. So let me write. Okay, this is x actually. You can see that okay, this is x power minus 1 is equal to 1 upon x power n. So let me write it this way, from this way. If that is in negative, n value is negative, then x will become 1 divided by x. X will become 1 divided by x and my power will be in positive now. Now here is power is in negative. I will make it a positive. How? just multiply again it with minus. Put the minus sign. So earlier that was negative, and I put minus sign. This make it positive. That's it. So this is, here we are handling the negative power. Here we are handling the negative power in this case. This is the complete base case. One last thing, okay, one last thing, please let me know. We are dividing our big problem into smaller problem, okay. Every time we are dividing this, and the power like 64, 64, then divided by 2, 32, then 16, then 8, then 4, then 2, and then 1. We are dividing every time the power by 2, and we can call this function recursively, because every time we are doing the same thing we are doing. So if we are doing the same thing every time, we can divide it, we can use the recursion. So let me use the recursion and call this, let me give a name to this function, POW, power. Okay, so this is a function, and we are calling this function. So let me call this function from inside, power function. I will pass the x as it is. X will not change. Okay, x will not change. What is changing? N. Every time I'm dividing the n by 2. That's it. That's it. So every time I'm dividing the n by 2, I will keep calling it. Okay, and whatever value will come, okay, let me store that into a temporary variable. So whatever value will come, like every time we will keep calling, like 64 to power 64, then this will be 2 power 32. Every time we are dividing this 64, 32, then 16, then 2 power 8, then 2 power 4, then 2 power 2, then 2. Okay, so by calling this function again and again and again, until unless we do not reach here, until unless our power become 1, here we will keep calling it recursively again and again. After that, we need to multiply it with the same number. We need to multiply 2 with 2. So whatever value I'm getting over here, whatever last value I will get is 1 actually. So whatever value I'm getting over here, I will multiply it to itself, because I need to multiply 2 power 2 into again with 2 power 2. I need to multiply 2 power 4 with 2 power 4. I need to multiply 2 power 8 with 2 power 8. 2 power 16 into 2 power 60, and so on I need to do. So here I'm just multiplying temp into temp. When we are rolling back, going upside, after coming downside by calling this recursion up to 1, then we are going upside, every time multiplying the same number to itself. One time we calculate it, and just we multiply it to itself to get the bigger solution, That's it. That's it actually. One last thing, okay, I can also add in this, otherwise this is the solution. One last thing we can add to handle the even and odd case, even or odd. So if the n value is even or odd, you already tell me that when n value is odd, then multiply the solution with x, multiply the solution with one more x. That's it. So let me finish that also. So if n is, let's suppose even, so I'm taking the mod with 2, and if remainder is 0 means n is even, then I do not need to do anything, just I will return the temp, else if that is not divisible by 2, that is not even, n is not even, you already tell me, return whatever is the answer you are getting, multiply that with the x, that's it, done. We are done. So we just cover in this code, actually we just try to cover different cases, like the negative, if power is negative, that case is covered. If n value is even or odd, that is covered. Here n value is even or odd. If n is odd, then we are multiplying our temporary answer every time with the x. So here we are handling even or odd. Here we are handling if the power is negative. Otherwise, just the code is this much. This is the base case. Every recursion have a base case, and here we are calling recursion and dividing our power every time by 2, and we are multiplying that to itself to get the bigger solution. That's it. Otherwise the code is this much only, but this is just handling the negative n value, and this is handling if n is even or odd. That's it. So I just pick this problem actually from the lead code. I'm going to over there itself. Any doubt in this, you can ask me if any doubt is there. Yes, and yes, Thomas, you are right. We are writing this code for the odd numbers. Fine, okay, if you are not able to understand, don't need to worry. Yes, okay, Praveen is come up with one another example. That's great. That's great. So let me take one example from Praveen and then we will move on. And this is actually nice question and that will be helpful for everyone. Praveen is saying that what about if x is 2, let's suppose, and n is 62. N is 62. Okay, if n is 62, what about that case? Let's see, Praveen, we are just executing it. This is 2 power 62 initially. Fine. Now we are dividing our 62 by 2. You are right, that will be 31. Fine. Now, in this case, actually, we are not multiplying. We are not going to the else statement. We are not going to the else statement to multiply with 2. No, we are not going. Because this is even. We don't need to multiply with 2. We are not going also. Let me write that statement once again. N mod 2 equal to 0. This is even statement. Then we are not modifying anything. We are just returning whatever is a temporary value, means temporary value, whatever value we have calculated till that time. So we are just returning as it is. Else we are returning what? Temp into x. So return this. Okay, this value is not odd, so we are not going to else. We will simply return whatever we will get after multiplying these two. After that, okay, this is now odd, so now we divide it by 2. So this will be 15 to power 15. We need to multiply it with 2. This will be multiplied with 2. This sub problem will come here. This sub problem while recursion will come here. At that time n value will be 31. So this condition will fail. We will go here and multiply it with 2. I hope you get the idea, and we can do this thing again. So it's not compulsory that you will multiply it 2 every time. No, it's not compulsory. Wherever will be the power while solving the problem, wherever will be the power will be even, we will not multiply. Whenever the power will be odd, we will multiply. That's it. For every sub problem we are doing, like here also we will multiply. Here also we will, because 15 is odd. Again 2 power 3 and 2 power 3, again we will multiply with 2 because 7 is odd. So this, here we are multiplying, but here we are not multiplying. Yes, this if else is handling that thing. I hope you we get this thing. Yes, clear, great. Fine, okay. Thomas, we will come to the space complexity also. First let's code this. First let code this thing, and then we will come to the space complexity of this. Otherwise, can you tell me how much space complexity right now this is taking? This solution which we discuss right now. Anyone? Praveen, Thomas, anyone or anyone else? Can you tell me this approach which we are using, how much space this is taking? How much is the space complexity for this? Time complexity is log n, we have already discussed. How much is the space complexity? If anyone can tell, let's see if anyone can answer this thing. If anyone can answer. Meanwhile, okay, you please answer in the chat box. I'm going to the lead code platform. Let me go to the lead code platform. So I pick this problem from the lead code. This is the same problem, and let me code this now. So I will do the same thing. You please Thomas, that is not order of n. Space complexity is not order of n. Think again and reply, please. That is not order of n. Please think again. Please think again. Meanwhile, I'm just doing the same thing. If you are not understand what I have done previously in the code, I'm repeating the same thing actually. I'm just copying and pasting everything what we discuss. So first I'm writing the base condition. You already tell me when n value will be 0, when power is 0, simply return 1. You already tell me. When power is 0, return 1. Already tell me. Already tell me. Fine, okay. Another thing you tell me, if n is less than 0, if n is less than 0 means power is negative, then you will replace the x with 1 upon x. So 1 upon x. That's it. And now the power will be in positive. Now the power n will be positive. So I am again multiplying it with minus, because earlier that was in negative. Negative will be positive. That's it. So here we were handling the power is negative case. If power is negative, n is negative, we handle this case. Fine. After that, we recursively calling. We are dividing our big problem into smaller problem. Okay. So let me take a temporary variable where I can store my temporary data. That will be keep multiplying upside, and we will get the solution. So to divide the problem into sub problem, I'm recursively calling this function. The function name is now my power, my POW. So I'm using recursive this function POW, and passing two arguments. We are receiving two arguments. One is x. X is not changing. Only n is changing actually here. N will be every time half, half, half. So x I'm passing as it is, and n will be n divided by 2. Fine. And after that, after dividing the problem into half, 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 then we will start roll back. While rolling back, we are multiplying that temporary number to itself every time, multiplying the temporary number to itself to get the solution of bigger problem. Okay, fine. So temp is equal to temp into temp. That's it. Temp equal to temp into temp. We multiplying the number with itself. We do not need to calculate it again. Done. We done with it. One more thing we can add over here to handle the even and odd cases. So for that we write just a if statement. If n mod 2 am I my camera is visible? Just a minute. Okay, fine. I think that is visible now. Fine, okay. I hope that is visible now. So let me complete this code. Thomas, I think this is visible now. Right now, please check again. Yes, Praveen. Okay, fine. That is visible. Okay, so here n mod 2 is equal to 0. I'm coming to your other questions also, but before that, okay, what we discussed till now, let's finish that. Let's finish that, and then we will take more questions so that we add more information. We get more information. Okay, but let's complete this one first. So whenever we are getting the even number, simply whenever we are getting the even number, simply return whatever value we calculated in the temp. Simply return that. Else return temp into x. That's it. One time we need to multiply with the x, otherwise. That's it. We're done with it. I think we're done with it, and we can now submit it. So let me submit this. Yeah, it's working fine. It's working fine. So yes, this what we discussed, that is working fine. And if you are a Java programmer, so let me share the same Java code is here. Just sharing the code in Java. Actually, the code is almost same. It's like this statement is same. Termination condition. If n value is 0, then we are returning 1. This is to handle the negative case. If n value is in negative. After that, we are dividing our big problem into smaller problem. This is what we do in divide and conquer. Divide the big problem into smaller problems, and then solving the smaller problem. Here we are solving the smaller problem. And after that, okay, this is one case of even and odd. If n value is even, we are not multiplying it with x. Otherwise, we are multiplying with x. So this is the code is same in the Java. And for the Python also, okay, let me share the same code. The people who are here in Python, so this is the, again, same statement. If n value is 0, return 1. If n value is negative, then again we are dividing x by 1 by x and making the n positive here. And after that, okay, calling this function again recursively, solving the problem and checking even and odd. That's it. So that's it. Actually, we solve this problem. Let me take now we first question I'm taking here is that after this, okay, let's add more information in this. What is the space complexity? What is the space complexity? Let's add that thing. This is not order of n. This is not order of n. Actually, we just let's see is what we have taken extra. We just take this variable extra and this variable extra. Okay, this is taking 8 bytes. This is also taking 8 bytes. Only two variables. Oh, one more. 10, you can say 8 more bytes. 8 more bytes. What will be the space complexity? We know space complexity. Space complexity is the input space. Input space what is input space? The space required to store the input. Okay, input space plus the extra space. Extra space, or you can say the auxiliary space. Auxiliary space. Auxiliary space is the extra space. Extra space required to solve the problem. Extra space required to solve the problem. Okay, input space, you can say that. Okay, you can say that. Okay, two variables you are taking as an input. You are just giving what input? X and n. Two variable you are giving input. So this is that you can consider. Okay, input space. Although this is you are defining over here, you can say that this is auxiliary space because input space is different. Again, that will be 16 bytes. Okay, so you are taking input here. Okay, let's suppose you're taking input here. So this is the input space. Directly we are taking input here. 16 bytes here is the input space plus extra space. You just consume one variable 8 bytes. 8 bytes. Total is 24 bytes. 24 is constant. 24 is constant. So the space complexity should be constant. But this is not constant actually for this solution. From this, we get that input space plus extra space, we get this 24 bytes. But auxiliary space, one thing more thing I'm adding over here. Last thing I'm adding. 8 bytes we take here. 8 bytes. Okay, I consider this one. There will be little more extra space. There will be little more extra space. Might be maximum student means like say this, they may say like this. They will say that okay, space complexity is constant. No, but that is not constant. Some extra space will be requiring. For what? For handling this recursion. For handling this recursion. Actually, when you will call this function, whenever you call this function, let's suppose we have 2 power 64 is our input. To solve this problem, you are calling 2 power 32 to power 32. So CPU will put this function inside this function will be put inside the stack. This stack will be maintained by the CPU. CPU is maintaining this stack. After that, to solve 32, you need to solve 2 power 16. All these previous functions will go inside the stack. All the previous function is going inside the stack. Okay, so how many functions go inside the stack? 1, 2, 3, 4, 5, 6. 6 functions are going inside the stack. You can say that 6 function. When n value was 64, 6 functions are stored inside the stack. You can say that okay, log of n is actually, you can say that okay, log of n is a space complexity, space required inside the stack. Or log of 64 is how much? Is 6. Log of 64 is how much? 6. So if n, based upon n value, you require 6 space here, 6 space here. So I can say that space complexity is how much? Log of this n, log of this n, log n. I can say extra space, more extra space required is log n. Auxiliary space more is log n. Why? Because of this stack, internal stack. Programmer is not maintaining this stack. CPU is maintaining. CPU is crying, why are you putting on all the burden on me? We are not bothered as a programmer where the stack is maintained and all that. But yes, this stack will be maintained by the CPU. Okay, fine. So what will be the total complexity now? I'm adding log n also here. I'm adding log n. So the space complexity is log n here. Space complexity is log n here. Yes, space complexity is log n here. Thomas is saying that, sir, for recursion, the internal stack formed is not being considered. That will be considered. That will be considered. Yes, this is we are considering. I just mentioned, okay, this space, and this is a space required to maintain that internal stack. And the size of that stack is actually not n, that is log n. That is log n. How many functions you call? Only 6 function in this case. Fine, okay. So due to that, I think, Thomas, you were thinking about the stack space will be n, or might be you're saying log n right now. Fine, okay. One more thing you asked, one more question that was also nice question actually. Can you improve this space complexity? Time complexity we cannot improve. Further, the time complexity we cannot improve. But can we improve the space complexity? Yes, we can improve the space complexity. Just what we need to do, rather than using recursion, we can solve it using the loop. By using iteration, we can solve this same problem actually. By iteration, we can solve this same problem. Then we will not be requiring this extra space. This extra space, this log n space will not be requiring. Then space complexity will be constant. Okay, let me do it. Let me do it with the iteration also. Let's do it with a little modification required. Little modification. Let me finish it. This also. So rather than calling the recursion, let me remove this part. So these are the base cases. This will be remain same. This will be remain. We are handling the negative n value. This is we are handling if n is 0. Otherwise, what we can do is, okay, I can take a result variable, initialize with the 1, and we can do this thing by a loop. Via loop, we can solve this problem, and loop will execute until we are reducing n value, n by 2, n by 2, n by 2. So until n is greater than 0, we can execute the loop. And what we need to do, every time I need to divide the n by 2, fine, and okay, we are dividing the n by 2. We need to multiply also x with x. X value is, let's 2. We are multiplying 2 with 2, then that will be 2 power 2. 2 power 2 with 2 power 2. So now we are going, earlier we were coming from top down. Now we are going bottom up. In this loop, we are going bottom up. First multiplying 2 into 2, then 2 power 4 into 2 power 4, we are multiplying over here. Okay, and let's have, that's it actually. But just need to handle the case of even and odd also. So for that also I'm putting one condition here. If n is, if n mod 2 is not equal to 0, okay, then okay, means that is odd. In that case, okay, we will multiply our result with the x. That's it. And after coming out of this loop, we can return the result. Fine, okay, done. The same thing we can whatever you can implement with recursion, we can implement with loop also. Okay, but in company we prefer that, okay, you write the code in recursion because that is more readable. For complex problem, that become more readable as compared to this iterative one. So if we submit it now, the space complexity we submit it. So now the space complexity is actually, yes, this is accepted, and space complexity is reduced to constant. Now, yes, Thomas, the space complexity for this code is reduced to constant. Fine. Here actually just we are going bottom up. There in the recursion we were coming from top down approach. That's it. Anything else you want to discuss? Otherwise, in today's session, let me summarize what we discussed. we just try to understand divide and conquer, how divide and conquer is helping. And this was really nice problem. I really means love this particular problem. Why? Because this give the gist of the divide and conquer approach. We are solving a problem. Earlier we were solving a power of a number, we were finding in order of n time. And so see, with dividing the problem into smaller problem, we reduce the complexity to log n. Okay, so dividing a big problem into smaller problem and then solving it, this might really help us to solve it efficiently. There are many algorithms which are using divide and conquer. Merge sort is one of the famous algorithm which use the divide and conquer. Quicksort do not use complete divide and conquer, means that divide the problem and conquer the problem. Quicksort divide the problem into smaller problem. Quicksort conquer also solve the smaller problem, but that do not combine the solution. So that is halfway, we say that use halfway divide and conquer, quicksort. But there are many algorithms actually which use divide and conquer approach to solve the problem. So this is a really nice technique, and you can practice now. My motive was just to give the gist of this technique, divide and conquer, and we solve one Google problem also. I hope you like this session. If you like this session, please give a thumbs up and write in the comment section. Next time we will come up with another concept, another Google problem. Try to understand it, try to consume it. That's it for today. Thank you for being with me. Bye bye, take care. Now I'm ending this session. Bye bye. So going to my PPT back. So bye bye.